Okay, we'll continue with the same chapter, calorimetry. Little bit theory part is left over, and after that we have to do only the problems of this chapter. And this chapter will go on. Last time I was talking about when we supply heat to a body, heat to a substance. Normally we see there is a change of temperature, there is a rise of temperature. But we see that there is no change in the temperature, there is no rise in temperature as well. That happens at times, and that time we find that the body or the substance is changing its physical state. Maybe a solid is changing into liquid, liquid is changing into gas and all. So that is called change of state. So during change of state, temperature does not change, temperature remains constant. And when there is no change of state taking place, that time temperature will be changing. Now today's heading is latent heat. Latent heat of a substance. Latent. The literary meaning of latent is hidden. Latent is hidden. Hidden heat. This is the amount of heat supplied or rejected by a substance during change of state. For the change of state, whatever is the quantity of heat involved, that is called latent heat of the substance. Or this is the amount of heat which does not change the temperature of the substance, rather it changes its state, physical state. Such a heat is called latent heat. Latent heat is so called latent, that is hidden, because such a heat does not change the temperature. How do we know whether a body is getting heated up or a body is cooling? How do we know? Normally we check the temperature. If the temperature is rising, we say that the body is gaining heat. And when we see the temperature is falling, we say that the body is losing heat. But body neither loses, temperature is neither increasing nor decreasing. Yet the body is losing heat or the body is gaining heat. Such a heat is called latent heat. This heat is called hidden because such a heat does not change the temperature of the substance or temperature of the body. That's why it is called latent heat. Then after we will be writing a specific latent heat. A specific latent heat. A specific latent heat denoted by, there is a symbol for it, capital L. A specific latent heat. The word specific coming, specific means unit mass. Always whenever you see the word specific, that means unit mass. Mass should be either 1 kg or 1 gram. In SI unit it should be 1 kg and in CS unit it should be 1 gram. What is the specific latent heat of a substance? We say it is the amount of heat required. It is the amount of heat required to change the unit mass of a substance, to change the unit mass of a substance, from one state to the other state, from one state, one physical state to the other state without any change in temperature, 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 without any change in temperature. Then there are two types of specific latent heats. We write as latent heat of LF. LF means a specific latent heat of a specific latent heat of fusion. And we write that is LV. LV means a specific latent heat of vaporization. L with the subscript F means specific latent heat of fusion, F for fusion and V for vaporization. A specific latent heat of vaporization. How to define a specific latent heat of fusion of a solid or of a substance? How to define? Fusion means melting. Fusion means melt. We say it is the amount of heat required to change the unit mass of a substance into liquid at a fixed temperature. At a fixed temperature. How to define LV? It is the amount of heat required to change unit mass of a liquid to change into vapor. Because this is the word coming from vapor. Vaporization is the process of changing liquid into vapor or into gas. So we write as LF value, LF for ice. LF value for ice is 336 joule per gram or 33600 joules per kg. And LV for steam, latent heat of vaporization of steam is 2260 joule per gram, or in SI unit 2260 and again 300 joules per kg. These are the two values we are supposed to learn by heart, these two values. Latent heat of fusion for ice, latent heat of vaporization for the steam. What is the meaning of this? Latent heat of fusion for ice is 336 joule per gram. Question may come, what do you mean by this statement? We say this statement means, we can see joule per gram. This statement means 1 gram of ice, 1 gram of ice will require 336 joule of heat, 336 joule of heat to change into water, to convert into water or to melt into water at a fixed temperature. And what is that fixed temperature? 0 degrees Celsius, the melting point. This is the meaning. So even question may come like this. A specific latent heat for ice is 336 joule per gram. What do you mean by this statement? Write down answer. We say this statement means that 1 gram of ice will require 336 joule of heat to change into water or to melt into water at fixed temperature, and within bracket you can add 0 degrees Celsius. Similarly, question may come, latent heat of vaporization for steam is this much, 2260 joule per gram or 2260 joule per kg. What do you mean by this statement? We say this statement means that 1 gram of water, because water changes into steam, 1 gram of water requires 2260 joule of heat to change into steam or to change into vapor at a fixed temperature, and within bracket you can write 100 degrees Celsius. That fixed temperature is called boiling point. 100 degrees Celsius you can write. So this is how you give the meaning of this statement. What is the SI unit of specific latent heat? What is the SI unit of L? I have written joules per kg. You can write down that. SI unit of L is joules per kg. Joules per kg. You don't have to write degree Celsius here or degree, Kelvin, because there is no change of temperature. This happens without change of temperature. So that you should not write here. Joules per kg only. If you compare the specific heat and the specific latent heat, you will find that the specific latent heat value is very high. What is the meaning of specific heat? Only specific, not the latent. Specific heat is the amount of heat required to change the unit mass of a substance or to raise the temperature of unit mass of a substance through 1 degree Celsius or through 1 Kelvin. So there, those heat is required to change the temperature. And this is the amount of heat required to change the state, physical state from one form to the other form. Like maybe solid to liquid. This will happen, this thing will be involved during change of state only. That means for melting, for vaporization, for freezing, for condensation, this amount of heat will be involved. And the value of the amount of heat involved for the change of state has got much higher value as compared to the SHC value. SHC, for example, SHC of water, you just have to look at it. SHC of water is how much? Only 4.2 joule per gram per degree Celsius. That is, for change of temperature of 1 gram of water we have to supply how much heat? 4.2 joule. And now let's see, to change 1 gram of water into steam, how much it is needed? 2260. So just compare 4.2 and this is 2260 and that is only 4.2. This is too small as compared to this one. Similarly, the value of latent heat is 336 joule here and oxygen is only 4.2. So latent heat value is in comparison to specific heat value is very high. Then it takes longer time for the change of the state rather than to change the temperature. So latent heat value by nature is very high. So always remember that. Okay, now there are recent test questions based on this fact, specific latent heat or based on the fact of latent heat. Latent heat value, the specific latent heat value is usually very high as compared to the specific heat capacity value, SHC value. This value is very high. Now the recent test questions you may get like this. Ice is more effective coolant than cold water. To cool something, that is to cool juice bottles or cold drinks and all, we use a lump of ice. We normally don't use the amount of water, some quantity of water, cold water we don't use. Rather we prefer ice cube on there. Why? What is the reason here? Because ice contains the latent heat. Ice will have to melt. So how will ice melt? Ice will be absorbing large quantity of heat from the hot substance which comes in contact with the juice bottles and all, with the cold drinks bottle. So it has the ability of absorbing large quantity of heat from the hot substance in order to cool it effectively. That means when you put, suppose we are having a block of ice here and some maybe juice bottles here like this. There are some juice bottles here. You are having ice cube here in contact. And in another situation you are having, this is you are keeping in water, just cold water. Cold water you are having. Cold water at 0 degrees Celsius. This is maybe cold drinks and all out there. There also you got cold drinks here inside. Or some juice, some liquid is there only. Ice will melt here when it comes in contact. When will ice melt? When it will absorb heat from the hot substance. But the ice will be absorbing the heat in the form of latent heat, the value of which is lower, the value which is high. We say the value which is very high. For example, specific latent heat of ice, fusion of ice value is 336 joule per gram. There is 1 gram of ice will melt by absorbing 336 joule of heat from the substrate. But out here 1 gram of water's temperature will change from 0 degree to 1 degree Celsius by absorbing only 4.2 joule of heat. Here 4.2 joule of heat is absorbing and this one is absorbing 336 joule of heat. Which absorbs greater quantity? Definitely ice, because it absorbs the heat in the form of latent heat, the value of which is comparatively much higher than the value of heat just for the change of temperature, for the rise of temperature. So here the ice can absorb large quantity of heat from this hot substance. That means the hot substance will be able to lose more heat and will become colder, much colder than the cold water. That's why to cool something we use a block of ice or lump of ice we use on here. So that is the idea behind. Then there are result tests with quite many questions. If questions are based on ice or steam, so our answer will be based on the fact of the latent heat. There will be answering on the question on the basis of the latent heat. Now another question, they say when there is a snowfall, the weather becomes cold, very cold during winter time mainly. The weather becomes very cold soon after the snowfall. You know the reason why? Because the snows will have to be melted. When will to melt the snows will be absorbing the heat. The snows being the piece of ice will be absorbing heat from the surroundings, and that heat it will be absorbing in the form of latent heat, the value which is very high, 336 joule per gram. That means the surrounding loses enormous quantity of heat in order to melt the snows, in order to melt the ice or the piece of ice over there. So surrounding losing large quantity of heat, the surrounding becomes very cold. So that is the idea. Similarly, they ask the question like this: when ice in the lake, when ice in a lake starts melting, the weather becomes cold, because ice will melt only when it will absorb the heat from the surroundings in the form of latent heat, the value which is very high. That is, surrounding will be losing large quantity of heat in order to melt the ice. The surrounding is very cold. So that is the idea. Any question based on ice are answerable based on this fact, latent heat fact. Sometimes they ask this question also, just the reverse of this. When water in the lake starts freezing, the weather becomes pleasant and warmer. When water in the lake starts freezing, the weather is pleasant and warmer. It's not cold, rather it is pleasant and warmer. Why? Because water is freezing, that is, water will be changing into the ice. When will it change into ice? When water will lose heat. Just the reverse process. Because when ice gains heat, then it melts. And when the water loses heat, then it changes into ice. That is called freezing. But the quantity of heat involved is same. So 336 joule is the amount of heat needed for ice to melt. Then 336 joule amount of heat will be lost by water in order to change into ice. The quantity of heat will remain the same. When water in the lake starts freezing, the water will be losing the heat to the surroundings in the form of latent heat, the value of which is very high. Why in the form? Because water will be freezing into ice. Again, change of state is taking place, and it will be this time losing the heat to the surrounding. This time the surrounding will be heat receiver, and that is in the form of the latent heat. So the surrounding is receiving large quantity of heat from the water out here, so the surrounding is pleasant and warmer. So that is the idea. It is just the reverse of this case, ice melting and the water freezing, just the opposite of that. Now, the another question may come in like this: all the ice in the Himalayas do not melt at a time, in a day. In a single day, all the ice present in the Himalayas, you think that all of them melt? If they all will melt, then there will be ecological disbalance. There will be floods all around, the water level will rise, and there will be lots of extremities, I mean the weather extremities will be there. So that never happens. You know why? Because to melt the entire ice, it requires large quantity of heat in the form of latent heat. And that much quantity of heat is not supplied by the sun in a single day. Sun also cannot supply that large quantity of heat to melt the entire block of ice. So all the ice in the Himalaya do not melt. So sun supplies whatever quantity of heat, with that the ice will melt partially, the glacier and all will melt partially there. So that is the idea here. So latent heat is quite useful, and we have many recent test questions based on the fact. Any question based on ice or based on the steam, we will be answering on the basis of latent heat. Now the questions on steam, they ask like this: why steam causes more severe burn than hot water or than boiling water? Because steam is a change form, steam is a vapor form, so it must be containing the latent heat, and the value of latent heat is very high. It is much even higher than the value of this fusion value. Fusion value is only 336 joule, whereas latent heat of vaporization value is, I have given the value 2260 joule. That means steam contains additional quantity of heat. How much additional quantity of heat? 1 gram of steam will have 2260 joule of additional quantity or extra quantity of heat it will have as compared to the boiling water, as compared to the hot water. So that steam is containing more heat because of the latent heat, so it can cause more severe burn. So that is the idea. Since steam contains the latent heat, which means the additional quantity of heat, the value of which is very high, you can give the value also. What is the value of the specific latent heat of vaporization? 2260 joule per gram. That means in comparison to the water, it contains additional 1 gram of steam contains additional quantity of heat that makes steam much more energetic than the plain water or than the boiling water. That's why it causes more severe burn. We say steam is much more powerful than the hot water because of this same reason out here. We have got a steam engine which pulls the entire train, and also in past we used to use steam engine for pulling the trains around. So because steam is much more energetic than hot water. So So that is the idea here. So any question based on steam also are answerable based on the latent heat, and the questions based on ice also are answerable based on the latent heat. One question is quite interesting, and then you can think about it. You are given cold water and the hot water. There are two choices: cold water and hot water, and we want to control a fire. We want to put off a fire. Which kind of water should be used? Hot water or the cold water? Is better for controlling a fire or for putting off a fire? Which one is better? There is a fire and we are having the choices of using hot water as well as the cold water. So which one we should use? We should prefer which one? The hot water or the cold water? This time the answer, think a little wisely, the answer will not be as common. Most of the students, they will go for cold water. They will think that cold water is very cold, so it will absorb more heat, and then we should use that one. Cold water only we should use. We should not use the hot water. But the actual answer is hot water. Hot water is preferred in putting out the fire or in controlling the fire. You know why? What is the reason? Why should we use hot water in that case? You always think a little differently. Okay, don't go for a common choice, because every student, they will go for the common choice, which is not the correct answer. So you have to think a little differently on here. So what should be the answer for this? The reason is, suppose there is a fire out there, there is a fire, there is a fire, and we are having hot water and we are having cold water here. Two choices. Hot water, what will happen if you put hot water, water is already hot, so it will reach the boiling point faster as compared to the cold water. When it reaches the boiling point, which is 100 degrees Celsius, then what it will do? Now it will start changing into steam. And to change into steam, it will be absorbing the heat, it will be taking up the heat in the form of latent heat, and the value which is very high. That means it can put out the fire, it will absorb the heat from the fire in order to change into steam in the form of latent heat, the value which is very high, and it will do it faster because its temperature is already high, so it will reach 100 degrees Celsius faster. So it can put out the fire faster. It can put out the fire quickly, more quickly than whereas cold water, what will happen? It will also do the same thing, but its temperature is already low, so it will slowly rise to 100 degrees Celsius. It will take longer time to reach 100 degrees Celsius. This will also is reaching 100 degrees Celsius. Then this will also do the same thing as the hot water is doing, but it will be taking longer time to do this. Because its temperature was initially low, so it will reach 100 degrees Celsius temperature. Then it will be absorbing the heat in the form of latent heat, the value which is very high. Then it will be putting out the fire. It will do the same thing as the hot water is doing, but it will do it in a longer time, in a longer period of time. That's why we say hot water is preferred or should be preferred to put off a fire, because it will put off the fire quickly, because hot water reaches the boiling point faster, so that it can absorb the heat in the form of latent heat, the value which is very high from the fire, and hence it can put out the fire quickly. That is the answer. Whereas the cold water reaches the boiling point, which is 100 degrees Celsius, slower as compared to hot water, then it will do the same work as the hot water is doing. So it will put out the fire, but it will take a longer time as compared to the hot water. So we should prefer hot water. There is a fire, we want to put out the fire quickly. We are not going for longer duration of time. So because both of them are capable of putting on the fire, hot water also cold. So we should prefer hot water. But the problem is hot water at all times may not be available. We cannot have hot water all the time present in a situation when there is a fire, because fire or which want to put off an emergency situation, so there is an accident case, so there the hot water may not be available, so normally we don't go for it. But if we are having choices of using hot water or the cold water, we should go for hot water. Hope you understood the logic here. And then okay, today we are doing this much. Little bit is the one graph is left over, that is heating or cooling curve, and after that the numerical problems. So that will be numericals will take a little time. So we'll be doing that. We'll be starting graph heating curve, cooling curve the next day, and then we'll be doing the numericals. Thank you very much for the day.